Friends, good morning to all. I would like to start with one interesting quote. Take up one idea, right? Make that one idea in your life. Think of it, dream of it, live on that idea. Let the brain, muscles, nerves, every part of your body be full of with that idea. Just leave all other idea alone. This is the way to the success, right? So it's a one industry code. You can also take it. Okay. Today we are going to discussing about the atomic structure. Today we are going to discussing about atomic structure. Atomic structure. Okay. So atom has structure, right? So before we moving to the study of atomic structure, I would like to talk about one scientist. He born in Manchester, England. We know that most of the scientists born in Europe, right? Europe, mainly maybe in Germany or England, right? So this scientist born in England, okay, Manchester. His father was a bookseller. He father is bookseller. He started his school at the age of 14 in Ons College. Okay. Ons College, later known as the University of Manchester. He studied there, and he later studied in Trinity College. Mathematics. He learned mathematics, studied, okay, and master degree also he completed, and he worked as a professor in Cambridge University, okay, famous university in England. He worked as a professor, right? And also he was a director of the Cavendish laboratory. So laboratory in Cambridge University. We know the Cavendish, William Cavendish and Henry Cavendish. They are the laboratories. Their names known as this laboratory. Okay. What I'm saying? Yes, director of Cavendish laboratory in Cambridge University. So that is known for the Faculty of Physics. Faculty of Physics is known as the Cavendish laboratory. And he also won in Adams Prize. Adams Prize, one of the prestigious prize in Cambridge University, especially for the mathematicians. And he also won Nobel Prize in 1906. His son also his son name is Paget. John Paget also won Nobel Prize in 1937. Rutherford, Niels Bohr, Oppenheimer, Bose are the notable students of the scientist, right? Anyone know the name of the scientist? And one important point also, main point also, he known for the is known for the discovery of electron. Now, yeah, is J.J. Thomson. Good. Joseph John Thomson. Joseph John Thomson. His scientist name is Joseph John Thomson. Born in England. Nobel Prize in 1906 for the discovery of electron. So we today discussing about his discovery, his experiment, his observation and research. Okay, J.J. Thomson. We know the year 1897 happened the discovery of electron. Yes, discovery of electron. Discovery of electron. We already learned, okay, electron, discovery of electron. But here we are going to study about the experiment, how he discovered it. Okay, discovery of electron. Okay, by whom? J.J. Thomson. J.J. Thomson. Joseph John Thomson. Okay, Joseph John Thomson. John Paget is his son, and he also Nobel Prize 1937. So what a scientist life, right? So atom have a structure. Previous class we learned the idea about the atom. Okay, atoms have a proton, neutron, and electron revolving around the nucleus. Okay, this is electron, this is proton, this is neutron, right? This is neutron. This is known as the orbit, the electron, the path of electron. Okay, that path is known as orbit, and this is known for nucleus, right? Nucleus. Inside the nucleus, proton and neutron exist. So the electrons discovered 1897. By whom? J.J. Thomson. Okay, proton discovered in 1911. Okay, 1911. By whom? Rutherford. Rutherford is one of the student of J.J. Thomson. And the neutron, 1932. So we are going to discussing the discovery of these particles. So that is atomic structure explained. So this is atom. This is the atom. Okay, this is the atom. Earlier we learned, in our lower classes we learned the atom is indivisible. Okay, atom is indivisible. Atom is indivisible. Atom is indivisible. We learned about the Dalton atomic theory. Okay, this atom is the concept, is the oldest concept, 5th century. The philosopher Leucippus and the Democritus, Leucippus and Democritus. Okay, the Democritus is student of Leucippus. They are Greek philosopher, famous Greek philosopher. Democritus. They first said about the concept atom, and matter is composed. Matter is made up of small indivisible particles called atom. Okay. Matter is made up of smallest indivisible particles called atoms. Right. So the atoms, I'm saying these philosophers are Greek philosophers. The name atom also, the word atoms also originated from the Greek word known as atomos. Atomos. Okay. This meaning is indivisible. Okay. Indivisible. Or we can say uncuttable. Okay. We cannot cut further. So this is exists in 5th century. In India also the same concept exists, but Kanata, what he says, matter is composed of smallest indivisible particles called paramanu. Okay, and also he explained the paramanu shape is spherical. That also important. Spherical paramanu. So these concepts exist in 5th century. So Indian concept also, Indian contributions also very important. So this concept exists up to the 1897. After that, what happened? After that, the discovery of electron happened because atom is divisible. Right? In the 19th century, lot of experiments, the experiments going on the physics, chemistry, science. A lot of scientists are also there, worked in the field of science. 18th century. We know that the modern science started in 16th century. Before that, there is no scientific proof or evidence is not exist. So modern science started with modern chemistry started with Robert Boyle. We know that the Anthony Lavoisier, their period is started with modern chemistry. So, and after that, lot of experiments will going on, right? So, 1897 discovery of electron, but Dalton what said? Atomic theory of Dalton in 1803. We studied 1 to 6 postulates. What are they? Yes, matter is composed of smallest indivisible particles called atoms. Okay, indivisible. That point is important. Indivisible. Okay, later it is changed. Atoms is divisible. And Dalton says atoms of the same element are identical in mass, identical in shape, identical in size. Atoms of the different elements are different. Dalton also said atoms is the smallest particle take part in the chemical reactions. Right? Atoms take part in the chemical reactions. The smallest particle take part in the chemical reaction is the atom. And Dalton also said different atoms combined in definite proportion form compounds. That also we studied, right? How the compounds form, and we studied the laws of chemical combination. 1 to 5 laws we are already seen. Based on that chemical combination, Dalton put forward the atomic theory, right? The atomic theory is on the basis of the law of chemical combination. We know that. And Dalton also said atoms cannot be created, not destroyed. Cannot be created and not destroyed. Atoms is indestructible. Right? That also we see. So Dalton atomic theory. 1803. 1803. So that happened. The 1803 discovery of electron 1897. Dalton died before 1897. He not know about the discovery of electron or some. He died before the 1897. So we are going to study the discovery of electron. Discovery electron by the discharge tube. That experiment is known as discharge tube experiment. Discharge tube experiment. Discharge tube means there is the gas is low pressure gas is there. Okay, the tube arranged with the two electrodes, metal electrodes connected with the high voltage electric batteries, generator or electric generators, and the inside the tube very low pressure gas. Why low pressure? Then only the charges move. The ionize the gas and charges move. Actually, the discharge tube developed by William Crook, and the tube is known as Crook tube. William Crook also observed the same things, the cathode rays inside the tube, but he could not be able to explain or study the properties of the rays, cathode rays, right? So we are going to the experiment of the Joseph John Thomson's discovery of electron. Okay, right? Are you getting what I am saying? Yes, good. So next we want to the J.J. Thomson experiment, his observation and his what are the result. Okay, so actually the study of atomic structure. Okay, the idea of electric charge. Right, idea of electric charge actually lead to the study of atomic structure. The idea of electric charge first given by Richard Thomson. Right, the electricity word first given by Thomas Brown. The idea of electric charge given by Richard Brown, and we know that the rubbing of substance creating a property of attracting property, that first given by William Gilbert in his book De Magnete. In De Magnete books, he explained about the attraction properties of when the rubbing creating attraction property. They attract some other substance that we see in physics also. Okay, we already studied in physics about static electricity, static charge. Okay, so what I'm saying, the idea of electric charge lead to the atomic structure, right? And the scientist John Stoney said, if the charge, the electric charge exists inside the atom, there he says, and he also named this charge electron. Right, the electron is a Greek word. He says the charges exist inside the atom, and he named this electron. Before discovery of electron, name already exists. Okay, so we are going to the J.J. Thomson's experiment, right? So just concentrate here. I already said discharge tube. Okay, we need a tube, that discharge tube. That tube known as discharge tube. That's why his experiment known as discharge tube experiment, discovery of electron, discharge tube experiment. Okay, discharge means release of charges. Charges are releasing. Discharge tube. Okay, it is a tube-like shape. tube experiment. Okay, right. Discharge tube experiment, 1897, discovery electron by Joseph John Thomson, J.J. Thomson. So we take tube. Okay, it's a tube-like shape. Okay, tube-like shape. Here one valve is small valve is there for lowering the pressure. Okay, lowering the pressure. So valve here low pressure gas is there. Very important. It's low pressure gas. Low pressure gas. Okay. Low pressure yes. Low pressure yes. So this is very important, low pressure gas. And what I'm here two electrodes are there. Two electrodes are connected. This is metal electrode. Electrodes are made up by metals. Right. What is the use of electrode? They conduct electricity in empties in the liquid or gas or means air or empty space. They conduct electricity. Okay, that's the use of electricity. Are you getting? When electrode, use of electrodes means electrodes are actually made up of metals, right? It may no, maybe no, most of the noble metals, maybe platinum or silver, like that. Okay, and it conduct in air, in gas, liquid. Okay, we study most of the experiment in liquid. So is connected with high electric voltage. Okay, that also important. High electric voltage. Why? Then only it is moved. Then only it is ionized the gas. Here is gas is there. When we applied high electric voltage, then only the inside the gas ionized. Okay. High electric voltage. High electric voltage. Why it is low pressurized? I said already, right? If high pressure is there, the charges cannot ionize and the charges not moves because there is high pressure. So low pressure means there is pressure is very, volume is very less. So the charges, this is we know the electric, the positive, negative side, the positive. When negative charge moves, we know the negative plate known as cathode. And what is the name of positive electron? Right, good. Anode. We know that anode. So when it is high voltage applied, the charges leave from here and here coated also. Okay, one coating is there, that is fluorescent coating. Mainly zinc sulfate. Okay, zinc sulfate. When it is, why it is coating? Before there is no we cannot observe the path of the rays, path of these charges we cannot observe. When it is coated with fluorescent, when it is the rays, the charges strike here, and wait, this is made up of zinc sulfate, then it is glow. It's a property of fluorescent. Okay, we already know the fluorescent bulb, how it is glow, like that. That property, so that uh, property is also here. When it is strike here, it is excited. Here this electron and down and emit the rays. So that's the properties of the fluorescent, that because of fluorescence only the rays observed. J.J. Thomson observed the rays. J.J. Thomson observed the rays, and he observed like this: the charges are going straight line. Charges are going in straight line. Okay, and he called very very important. Okay, very very important. He called it cathode rays. Cathode rays. Why? Why he called it is cathode rays? Why it is called? Yeah. Yes. Very good. Because it is come from the rays. The charges coming from the rays come from cathode. Right. Cathode plate. That is negative plate. Because of that, he called it is cathode rays. So he observed the straight. He observed it's going the straight line. So this is our first observation of J.J. Thomson's discharge tube, and what he did after that. For the study of these rays, he placed it electric field and magnetic field. Electric field and magnetic field. So we are going to electric field and magnetic field and what happens. Okay. So rubbing this. You're getting? Yeah. We are going to the discharge tube. He placed in electric and magnetic field. Okay, this discharge tube connected with electrode, metal electrode. Here small hole is there. Okay, for the rays going through that small, connected with the high electric voltage. So firstly there is no electric and magnetic field. What we see the experiment, the rays are going straight, and here a scale is there. For what? For what we are using scale? Measure. So the measure the deflection of the rays. Okay. So there is no deflection. This is cathode, anode. Okay. You remember. I'm not representing here. Just remember that this is cathode, anode, and rays come from the cathode. There is no electric and magnetic field. Nothing is there. So the rays go in straight line and strike here and glow. So here also quoting. Okay, that also remember. Here we just observe what is his observation. We see. Okay, I'm not labeling, and he placed it in electric field. What happening in electric? Okay, small hole is there. This is the anode, cathode. Okay, connected with the high electric voltage, and when applied it, and also this is also connected with the electric field. Okay, electricity here. This is also connected with batteries. Okay, negative and positive terminal. This is a plate. Okay, so negative here is positive. You maybe think why it is here negative, here positive. It is opposites also. We can apply here negative, here positive. No problem. But here we take like this. So what happened? What happened is the here also scale for measuring the cathode rays. Why cathode rays? It is come from the cathode. So here also measuring scale. Okay. and here also coated with fluorescent. So what he observed, very very important, what he observed? He observed that the rays, charges moves downward. Charge moves to downward. Okay, charge moves to the downward, not straight line, not opposite, moves to downward. Okay, moves downward. So he measuring. Okay, various experiment. A lot of time he doing this experiment. Okay, not only one time. The experiment going a lot of times. Okay, then only we can detect this. Okay, suddenly we cannot observe anything. Okay, experiment, and he noted it. Okay, so deflection downwards. So here positive, here negative. So negative to the electric field, negative to positive is the force. So the force direction is like this, electronic force, negative to positive. So it may be, why it is no here attraction to the positive charge, right? Next we are going to what happened in magnetic field. Okay, when we applied the magnetic field, what happened? The deflection. Okay, so we take a discharge tube, separately done first. Okay, same as they connected with high electric voltage. So here is the magnet. Okay, observe here carefully. Okay, we place here like magnet like this. Okay, magnetic is like this, magnetic like this. Inside the magnet we placed with the discharge tube. So here south pole, here north. We know that when this the movement of charge, what happened? He observed that the rays goes upward. Here also scale. Okay, same as first. Also coating also. Then only we can observe the path of the line. So north and south. Okay, when we applying the left hand rule, right? When we applying the left hand rule, as we know that the north, south, north. Okay, this is the thrust force. Okay, the direction of thrust force, direction of the field, north to south, and this is the direction of current. Okay, direction of current. We don't not confuse with, okay, this direction of current, not direction of charges. Direction of charge opposite the direction of charges is direction of current. That's important. We studied physics. So the force is upward. Okay, force is upward. So now you want to say what happened when electric field and magnetic field both applied together. What happened? Just imagine you what happened. Electric, when we applied electric field, it goes to the positive side downward. When it is applied magnetic field, when placed magnet like this, okay, north and south, when it is opposite, we place like opposite side, it is downward. Okay, so when we place like this, then it is upward. So same, we place together. What happened? Anyone? No? Yeah, we can just see. Okay, we just see. Same, the negative, positive plate. Okay, this is also connected with battery. Okay, positive and negative terminal. Okay, when it is applied downward. Okay, So force. So what happened when magnetic, same time magnetic field also, yeah, okay, magnetic field also we apply south and north poles. Two poles are there. So what the force? Force is upward. Okay, here you noted M. Okay, not E, M. First force. Okay, so magnetic. So force upward. So there's no force. So here there's no deflection. We cannot observe any deflection because it is going the same with the electric and magnetic field, the force opposite directions. So it is a straight line, no deflection. So he done with the various deflection and this experiment he observed various deflection, electric and magnetic field. Uh, he find out some of the points. What are his findings? His conclusion? What is after the experiment that is very important. He studied the properties of these rays, cathode rays properties when it is placed in electric field and placed in magnetic field. So what are the properties of cathode rays? He first said what the cathode rays travel in a straight line. Travel in a straight line. Cathode rays travel in a straight line. He said cathode rays are the smallest particle. Cathode rays are particles. That is important. Cathode rays are particle. Cathode rays are traveling in straight line. He said cathode rays deflect in electric and magnetic field. Okay, electric and magnetic field. When electric field applied is positive side, and when magnetic field applied it is moves upward. But it is expected for negative charge. But he expected for negative charge when it is moves upward. So here the downward. So what is the third point? First point we studied, it is moves in a straight line. Second one we studied when it is what I said. Yeah, it is a particle. And why I am saying the particle? Before that, there is a German scientist and a British scientist. There is a contradictory. There is some conflict between, but the German scientist said it is not particle, it is a wave, right? Like light. But the English scientist said it is not waves, it is particle. So last, what said J.J. Thomson said, English scientist, it is a particle. It is a particle. So that's the second point. It's a particle and it is deflecting electric and magnetic field. Next point, fourth point. It is the cathode rays penetrate very small thin metal sheets. Okay, when we place very thin metal sheets, mainly gold or some sheets, it is penetrate. It have energy. So penetrate. So that is the fourth point. So what I said, first it is a straight line, past straight line, deflecting electric and magnetic field. It is a particle and it is penetrate thin sheets, metal sheets. So this is important. And he concluded that, he said that these charges are electron. He said these charges are electron. So cathode rays are electron, movement of the electron. Okay, that rays is movement of electron. So that is the main important experiment of and discovery of the Joseph John Thomson. And also he found that the charge by relationship between the charge and mass. He discovered charge and mass, that is we call charge to mass ratio. He found that 1.76 into 10 to the power of 8. He by mass 1.76 into 10 raised to 8. This is the relationship. How he found that? Through the experiments of deflection observed in electric and magnetic. He also said he also said the size of the electron, that is the particle size of the particle, approximately 1 by 1. He found that through the experiments of deflection observed in electric and magnetic. He also said the size of the electron, that is the particle size of the particle, approximately 1 by 1836 of mass of hydrogen. 1 by, so you can imagine how it is very small. 1 by 836 of mass of hydrogen. Okay, so these things are you must remember always. Discovery of electron. What is his experiment? It's a simple experiment. When we see, it's a simple experiment. Discharge tube we need, and two electrodes and electrodes connected with high electric voltage, and when high electric voltage applied, the charges are releases, and it charges ionize the gas, and the charges moves and strike the end of tube, and there is the end of tube, the fluorescence are coated. The fluorescent coated mainly with zinc sulfate. So when it is strike the fluorescent, it is glow. The glow appears. When the glow appears, we can observe the path of rays, and he observed the path of rays. And then after he placed the discharge tube in electric and magnetic field, and he observed when it is electric field, but he observed some result from electric field applied and magnetic field applied, and then he put together electric and magnetic field. Then he studied and he find out the charges are particles, the straight line, travel in straight line in electric field, in deflect in electric and magnetic field, and it is penetrates thin small sheet. And also he said that it's a very small, and the size is equal to 1 by 1836 of masses of hydrogen. So its mass very less, small. So and he found that it is a smallest particle, first subatomic particle. Okay, it is a first subatomic particle, and he called electron. So electron is the first subatomic particle. So later we see in the charge of electron by Mulligan experiment. So in this chapter, various experiments are there. Rutherford experiment, we know Rutherford discovered what discovered. Yes, proton. Nucleus also discovered by Rutherford. There is a positive charge inside the atom. He got right. That experiments we see later. Okay, Godfoil experiment. So and later Chadwick. So here when we side the cathode rays, okay, so there is anode plate is there, anode is electrode is there, so there is anode rays is there, you think, okay, cathode rays is there, if any anode rays is there. So there is one scientist there, Goldstein. Okay, he also observed the anode rays, positives, right? So there is a positive is also that we discuss. He only observed, okay, not discovered, not studied. Goldstein only observed, but discovered only Rutherford. There is a positive charge discovered by Rutherford, but observed by Goldstein. And later we see, after that we see some of the model of atoms. Atoms have a structure, so some model also there. Some scientists, J.J. Thomson's, uh, some one models, and Rutherford one model, and then Bohr's model. These are the models are classical mechanics, classical physics. That's the macroscopic view. So, and later it's models also we study the quantum mechanical model. Okay, quantum structure based on the energy that they said it's a wave-like character. Also we see. Okay, so this class I think you got something. So you just remember all these points, and also you remember when we going to study about the scientist background, also you just remember one or two points. And also J.J. Thomson one autobiography, recollection and reflections. That's J.J. Thomson's autobiography, known as the recollection and reflections. Okay, so that also you remember. And also you remember in 1890 century there are a lot of scientists work in this field, atomic structure, and ideophyletic charge actually lead to the study of electron. Okay, study of atomic structure. So, and later this to remember the Rutherford is the students of J.J. Thomson. So next class we studied about the Mulligan experiment, the discovery of charge. Not discovery of charge, charge of electron. Discovery of charge of electron by Mulligan oil drop experiment. So thank you for the listening this class. If you have any doubts, you can ask. Okay, so thank you very much.